Good day, my dear children. Today we will be starting with the chapter Motion in Physics. I'm going to write down a few key points first on the board, which we will be learning in today's session. The first is the topic itself, motion, and related to that, rest as well. The next key point I'm writing is origin or reference point. The third concept we will be learning is distance, displacement, and once we cover distance and displacement, we will go ahead and learn what is a scalar quantity and what is a vector quantity. So as we go ahead with the chapter and we finish that particular part, we will come back and put a tick against it to make sure all of us are on the same plane and we have understood the concept. I think we're good to go now. We'll start with the first point, which is motion and rest. These two are opposite terms as of what we know till now. Now what do we exactly mean by motion? When I tell you motion, all that comes to our mind is something which is moving, right? But motion is not movement only. I am standing here at one place, you are sitting there on the chair in one place. Are we moving? Are we in motion? What is the logical answer that comes to our mind? No, we are at rest. Okay. Where are we? We are on planet Earth, right? What is planet Earth doing right now? It is revolving around the sun. So if we are on planet Earth, does it mean we are also revolving around the sun? The obvious answer is yes, which means we are actually moving though we seem to be at rest, right? I hope the concept is clear. So now we will come to the second point, which is origin or the reference point. How do I know something is moving? I am standing here and a boy runs in front of my eyes, right? Why do I say the boy is in motion? Because I am stationary, right? I am not moving, but the boy who has passed before my eyes has moved. So when I am talking about motion, I always talk about it with reference to a reference point or origin. Okay? For example, in the solar system, right in the middle of our solar system, we have the sun, right? We will be looking at this in a PowerPoint towards the end of the session. Now we have the various orbits around which, the planets revolve around the sun. Okay? I have Mercury here and I have the sun here. Why do I say Mercury is moving? Because if I am going to stand here and look at Mercury, I will find that the position of Mercury will keep on changing with respect to time. Right? If Mercury is going to be here, say at 1 p.m., if I am going to stay here only, I will find that at 3 p.m. Mercury has reached here. Right? So this sun, which is stationary, is the reference point. With respect to the reference point, this object is moving. So this object is in motion, whereas this is at rest. Right? So whenever we talk about motion and rest, please understand it is always with reference to an origin or reference point. उस point से क्या वो दूसरा body move कर रहा है? If it is moving, it is in motion. If there is no change in its position with respect to time, this object is not moving, it is at rest. Another term we could use for rest is it is stationary. Stationary is there is no change in the position of the object. So what have we done basically till now? We have covered what is actually motion and what is an origin or reference point. We come to the third concept which we are supposed to learn now, which is distance. What am I going to do now? Now this is my house, right? I have to reach a place which is over here. How do I go from A to B? Right? There's a particular distance involved. How am I going to travel that distance? I could go like this. I could go like this. I can also go like this. And if I have too much time on my hand and a lot of petrol to spare, I can also go like this. Right? So what are we doing here basically is we are starting from point A and reaching point B. The actual path that we follow, actual path is the line that I have drawn here. This is the actual path, that is called the distance, right? So, if I go from A to B using this wave path, maybe I will travel 20 kilometers. If I use this semicircular path, maybe I will fall a little short. I will take an 18-kilometer route. But the third part, which is absolutely going around, I would spend petrol and maybe travel 30 kilometers. So, how do I reach from one point to another? The path that I take, that is called as actual distance. Okay? Now, I have to go from A to B, right? I have only half an hour in hand and only a little petrol which is already reaching the reserve in my bike. Will I dare to take any one of the three paths that I have drawn? Absolutely not. What will I do? I will follow the fourth one here, which is I will go on a straight line from A to B. Why did I do that? Because this is the shortest distance between the starting point, which is A, and the end point, which is B. By doing this, I am doing two things. Number one, I am saving on the fuel. Number two, I am saving time. So the shortest distance between the origin and the end is called as displacement. Right? So while distance is the actual path traveled, we had three actual paths. Displacement is the shortest distance between origin, which is the starting point, and the end point, which we may also call as destination. That is the difference between distance and displacement. Having covered these four parts of the key points till now, what I'm going to do is take a quick recap of all the four and then go on to cover scalar and vector quantities. We will now go through a quick recap with the help of the PPT that's going to be presented. We started with what is motion and what is rest. We understood that these are relative terms. Relative means with respect to something else. What is the other object doing? We also went through this same example of the sun in the middle of the solar system and the planets around it. Right? So when an object changes its position with respect to a stationary object, this one is said to be in motion. Right. Now the next slide. I want to introduce a few terms which I didn't talk about. There are something called controlled motions and uncontrolled motions. Controlled motions are motions which we can actually regulate and use it for our advantage. But uncontrolled motion usually refers to natural calamities like earthquakes, tsunamis and all, where we have absolutely no control and it leads to a lot of damage. The types of motion, it's a quick brush through of what you've already studied in 8th standard. We have motion along a straight line, which is called a rectilinear or linear motion. We have circular motion, we have rotational motion and vibrational. Vibrational can be either up and down or sideways, And we also have the oscillatory motion mentioned in the diagram here, which is the typical motion of a pendulum. The next slide. Now motion along a straight line, this is what we are actually studying, and we learned what distance is. Distance is the actual path length covered by a moving object, right? We always talk about the distance with reference to an origin or a starting point. When we speak distance, I will talk only about how much have I covered, right? So we will mention only the numerical value of how much we have travelled, and we will never mention the direction. Distance is typically measured in kilometers, meters and centimeters. We then went ahead to talk about displacement. Displacement is the shortest distance between the start and the end, right? Displacement, very important, is when you are talking about displacement, you will definitely mention the direction in which the object is travelling, right? For example, I travelled 5 kilometers north from origin to the end point. So then what will the listener know? He will know that, oh okay, if I am at the origin, if I travel 5 kilometers north, then it is the shortest way to reach my destination. So it becomes important for us to mention the direction in displacement. The next one. This is a typical representation of the origin, which is point A. My destination or end point is point D. As we know, these wavy lines here, they all are illustrative of the distance that you can travel, right? So the total distance in this case will be A to B plus B to C plus C to D, right? But what is the shortest way I can reach from A to D? It is this straight line here, which is north-east. So this green lines here represent the distance and the red line represents the displacement. Another important point to remember is, suppose the object goes from A to D, right? And it comes back to A along the same path. What is my total displacement? It is 0. Why? Logical. Wherever I started, which was the origin, I have come back to the same place. So, this is a very important point. When the origin and the final destination points are the same, this means the displacement is 0. But can distance be 0? Distance can never be 0, because I have to go from this point to that point, and this is the actual length. So distance can never be 0, but displacement can be 0 if the object comes back to the starting point. Now, based on what we've studied till now, we are quickly going to learn what are vectors and scalars. Scalar quantity is a magnitude only quantity where I will mention only the actual distance or the number. But vectors have magnitude and direction. So my dear children, by this point it's very clear. Distance is a scalar quantity because I will mention only the number. But displacement will be a vector quantity because I will mention the distance as well. Distance and direction as well. Having covered all the points which we started out at the beginning, we now go on to see a quick video for recapitulation. Thank you.
When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered will be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance travelled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and travelling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.